Aberdeen Proving Ground, Maryland, December 1957. Major Robert Hunter stared at the fresh report, the letters blurring before his eyes. After 3 months of forensics and tests in the best laboratories in the United States, the conclusion was absurd. Soviet armor is garbage. The steel was oversaturated with impurities. The casting was crude, porous, and filled with internal cavities. By American military standards, it was second-rate material. Defective scrap that should have shattered upon the first serious impact. But on the firing range, nothing went according to the textbooks. Hunter had seen with his own eyes how this junk shrugged off hits that would have turned the latest American patents into Swiss cheese. Shells ricocheted and armor-piercing cores bogged down helplessly in the metal. The major ran his palm over the rough, irregular cut of the turret. The cold metal held a secret. How could steel that was inferior in every technical parameter provide the best protection in the world? Hunter didn't know yet the secret wasn't hidden in a chemical formula. The answer lay in the very essence of how the Russians think about war. Budapest, November 1956. The city was choking on gunpowder smoke. Shadows moved through the streets with clanking tracks, the secret Soviet T-54s. Moscow guarded this machine like the Holy Grail, reluctantly showing it even to their closest allies. Ferenc, a young Hungarian rebel, gripped a Molotov cocktail. The smell of engine oil and cheap rags filled his nostrils. When the steel monster stalled at the intersection, Ferenc hurled the bottle directly into the engine compartment. A flash screams from the crew, thick black smoke. The tank died, but its armor remained intact. Ferenc had no idea he was holding the Cold War's most valuable trophy. The CIA moved with lightning speed. Gold-bribed border guards and a night recovery vehicle running with its headlights off. The scorched T-54 crossed the Austrian border, and a week later it was sailing across the Atlantic. The cost of the deal remains classified to this day, but rumors suggest it exceeded the price of 10 brand new American patents. At Aberdeen, Major Hunter personally received the cargo. Cut it into pieces he ordered. He had no inkling that these chunks of metal would shatter every dogma of Western military science. January 1957, Hangar Number 7 at the Aberdeen Proving Ground. The gas torch hissed, scattering a fan of sparks into the heavy scent of burning metal. Technician Jimmy Collins guided the flame across the T-54 turret like a surgeon with a scalpel, while Major Hunter recorded the specs. Nearly 8 inches of front armor sloped at 60 degrees. When the red-hot segment finally gave way, Collins stopped working in disbelief. The cross-section of the turret revealed a strange sight. The metal was inconsistent, with layers of varying density and air bubbles and micro-cracks visible inside the steel. "This is pure garbage, sir," the technician exhaled. "At our plants, people get fired for this." American military science could not believe its eyes. They were used to flawless casting and perfect alloys, but here they saw crude wartime craftsmanship. But Hunter remembered the reports from Korea. These defective Soviet tanks survived hits that were guaranteed to destroy American machines. A secret was hidden in this porous steel that defied the logic of Pittsburgh metallurgists. February 1957. Aberdeen was gripped by 5-degree frost, but the test site was heating up. The T-54 turret was set up against the 90mm M41 gun, the pride of the U.S. Army, a weapon that cracked German tigers like walnuts. Major Hunter froze at his binoculars. Distance 500 yards, straight-angle fire. The roar shattered the silence, and the shell struck the dead center of the frontal armor. When the smoke cleared, Hunter could not believe his eyes. There was only a jagged dent on the turret. No penetration. "Close the distance to 300 yards, he commanded. They rolled the gun nearly point blank. A second shot, a third, a fifth. The rounds heated the steel to over 200 degrees. Sparks flew from the armor, but it stood firm. Chief metallurgist Dr. Reynolds turned pale. By all calculations, this second-rate steel should have been turned into Swiss cheese after the very first hit. But the Soviet turret seemed to laugh at American power. Then came the ultimate weapon, the heat round. Americans were proud of this technology, a jet of molten copper designed to burn through any steel like a hot knife through butter. The shot rang out, and a blinding flash momentarily flooded the range. Hunter rushed to the turret, expecting to see a clean hole through the side, but it wasn't there. Instead, only a shallow crater remained on the armor with melted edges and a layer of soot. The high-power energy jet capable of piercing feet of concrete simply vanished, choking in the thickness of the Soviet metal. Dr. Reynolds' voice trembled as he examined the impact point. "This is impossible. Something inside stopped it." Hunter silently stared at the rough cut of metal with those same air bubbles. A hunch flashed in his mind, something too simple for any academic in Washington to believe. "Cut it again," the major ordered, "right through the impact point. I want to see where our copper is buried." Night. Hangar number 7 was bathed in the deathly light of floodlights. Hunter leaned over the new cut of armor where the shaped charge jet had frozen after penetrating only 3 inches. It looked like a river that had suddenly hit an invisible dam. Dr. Reynolds held a magnifying glass to the metal and spoke softly. "Air." He pointed to the tiny cavities and bubbles deep within the steel, the very things Americans considered a sign of production failure. The physics of the process were staggering. Under monstrous pressure, a shaped charge jet melts through monolithic armor and surges forward, but the moment it hits an air pocket, it instantly loses focus. The pressure drops, and the energy dissipates. It worked like a bullet hitting water. The non-homogeneous medium neutralized the impact faster than any super-strong alloy. Hunter ran his finger over the porous metal. Every defect in the Soviet casting was a lethal trap for Western shells. While America spent billions creating flawlessly pure steel, the Russians turned imperfection itself into impenetrable defense. Hunter smoked one cigarette after another, staring at the mangled hull of the T-54. The smoke was as bitter as the truth revealed that night. For 20 years, American industry had fought for absolute steel purity. Billions of dollars, thousands of scientists, and flawless casting without a single bubble. The West was building perfect mirror shields. The Russians took a different path. They didn't try to make the steel perfect, they made its imperfection work for them. Every air bubble and microcrack in this defective armor was part of a system that turned a monolithic shield into a viscous trap for swords. "We bet on resources, they bet on cunning," Reynolds said, looking out the window at the dark proving ground. While American engineers simply increased plate thickness, their Soviet colleagues studied the physics of impact, looking for a way to cheat the shell itself. It was a clash of two worlds, a world of unlimited money versus a world where scarcity and necessity birthed brilliant simplicity. Reynolds stepped to the chalkboard and began drawing diagrams that made Hunter's old wounds ache. "A 60-degree slope isn't just a fashion statement, Major," the chalk screeched in the silence of the hangar. "It's the pure mathematics of survival. At such an extreme angle, a shell travels through twice as much metal as its nominal thickness, not 8 inches, but 16. But the key was the glancing blow effect. The impact energy didn't concentrate at a single point. It distributed along a tangent, forcing the armor to work against shear forces and causing the shell to ricochet helplessly. The Russians were the first to realize that a turret shouldn't be a wall, but a streamlined sphere. To an American engineer, the task was simple. If you need protection, make the steel thicker. But the Soviet designer, squeezed by the grip of shortages, didn't think about strength. He thought about how to trick the physics of ballistics. They created more than just a tank. They created a system where geometry replaced tons of expensive metal. The Urals, winter of 1943. The evacuated factory number 183 lived to the rhythm of endless thunder and freezing winds. Designer Alexander Morozov sat over his blueprints, his eyes inflamed from lack of sleep. On his desk lay terrifying reports from the front. German Tigers were sniping his T-34s from over a mile away. The tanks that were the best at the start of the war were turning into burning coffins. One tanker who lost his legs at Kursk wrote to him, "Comrade designer, make it so that others don't burn." Those words became a personal challenge for Morozov. But how do you protect a machine when steel is scarce and every extra pound of weight kills mobility? Would you like me to continue with the next part of Morozov's struggle to get his design approved? Morozov stopped thinking of armor as a wall. He began drawing the trajectories of incoming shells. A shell is not an enemy. He realized it is a physics problem. If you cannot make the armor thicker, you must force the shell to strike at a glance. A flattened spherical turret and sharp hull angles appeared on his sketch, a tank designed not to take a hit, but to cheat it. This was the blueprint for the future T-54. Nizhny Tagil. January 1944. The factory director's office was smoky and cold. Morozov stood before a commission of officials and military reps with the T-54 drawings on the table, the machine that was supposed to change everything. "Are you suggesting we divert resources to experiments in the middle of a war?" the military rep asked with a heavy stare. "We have a quota of 1,000 T-34s a month, and tankers die for the motherland. That is their duty. My tank will cut losses in half," Morozov replied quietly but firmly. "That means thousands of lives saved." But the bureaucrats were unyielding. They wanted numbers in their reports right here and now, not long-term developments. The project was rejected as untimely. Morozov was left alone in the empty office staring at his rejected dream. For the next 3 years, he would flood Moscow, the general staff, and the government with letters only to receive dry rejections time after time. He knew that while they argued, men were still burning on the front lines. March 1945, Moscow Kremlin. Reports on the latest German King Tigers lay on Stalin's desk. Massive, heavy, and nearly invulnerable, they seemed like the harbingers of a new era of tank dominance. Morozov stood before a map, feeling the heavy gaze of the leader. He had only 20 minutes to prove that the future belonged to intelligence, not mass. He didn't speak in slogans. He explained the physics of tangential stress, drew diagrams of ricochets, and proved that the T-54 was a tank that could not be destroyed simply by making a bigger gun. "Are you claiming, Comrade Morozov, that this tank will remain relevant even after the war?" Stalin asked slowly, lighting his pipe while looking at the drawing of the low-profile spherical turret. "It will become the standard for decades," the designer answered firmly. Stalin remained silent for a minute that felt like an eternity to Morozov. Then he took a red pencil and directly on the title page of the project he wrote 7 words. "Approve, provide everything necessary. Deadline yesterday. I, Stalin." It was a death sentence for old dogmas and a ticket to life for a legend. The victory of 1945 was followed by a heavy hangover of testing. The first production T-54s coming off the assembly line were a disaster. At the proving grounds, the machines literally fell apart. Cylinder blocks, cracked transmissions jammed, and road wheels sheared off. The tank that was perfect on paper refused to fight in reality. Would you like the final segment covering Morozov's personal struggle in the field and the ultimate legacy of his machine? Morozov went weeks without sleep. One night when temperatures plummeted to 22 below zero, he personally crawled under a tank. Without gloves burning his skin on the frozen metal, he disassembled a jammed gearbox right in the field. His fingers froze to the gears, leaving blood behind, but he had to understand why his brilliant idea was stalling in the mud. The reason was mundane subcontractors were cutting corners and violating the heat treatment protocols. Morozov secured the arrest of several factory directors. He knew that more than his reputation was at stake, it was the country's ability to defend itself in a looming nuclear war. The T-54 was born in agony through the pain and fury of its creator, forged from defects into a perfect instrument of war. In 1957, while technicians at Aberdeen studied the metal, Langley analysts were uncovering the identity of the man behind the project. Major Hunter flipped through a thin folder marked Top Secret. He expected to see the biography of an academic and elite university graduate surrounded by a staff of scientists. Instead, the face of a man with only a basic technical college degree stared back at him. Alexander Morozov. No Western internships, no work in advanced European laboratories. His entire academy consisted of the cold shops of Kharkiv and the harsh reality of evacuation to the Urals. Hunter realized something terrifying. While American intelligence hunted for German nuclear physicists, the Russians entrusted their main striking power to a self-taught designer. A man who learned to win not because of an abundance of resources, but despite a total lack of them. This very scarcity forced Morozov to think outside the textbooks. His genius was a product of survival, not comfort. The Pentagon remained silent for a long time. Generals did not want to admit that their technological superiority was an illusion shattered against the hull of a defective Soviet tank. But the numbers didn't lie. During the Berlin crisis, it became clear that in a direct clash, American M48s would be easy prey for T-54 divisions. Only then, in the early 60s, was the funding finally found. America began feverishly copying Morozov's ideas. This led to the M60 and later the famous Abrams. Their designs no longer featured vertical walls, only sharp angles, composite protection, and those very air cavities that Major Hunter once mistook for production flaws. It took Western engineers 20 years to realize that the Russian secret wasn't in the metal, but in the ability to do more with less. While Washington built expensive and complex systems, Morozov created a universal tool that a former peasant could maintain, but that the world's best gun could not pierce. It was the most painful lesson of the Cold War. A designer's intellect proved more powerful than a superpower's industrial budget. The T-54 and its direct descendants became the most produced tanks in history, with over 100,000 units rolling off assembly lines. They fought in 50 countries, survived dozens of conflicts, and 70 years later, they remain in service. A man with a technical diploma single-handedly changed the global history of armored vehicles, forcing the entire world to play by his rules. Colonel Hunter, after completing his service, wrote a book about Soviet tanks that U.S. authorities kept classified for nearly 40 years. In the final chapter, declassified only in 1995, he left a bitter admission. "We thought we were superior to the Russians in everything money, technology, quality. We were wrong. They surpassed us in the most important thing, the ability to squeeze the maximum out of the minimum." Today, history is coming full circle. American tanks cost $10 million apiece, remaining the most expensive in the world. But on the battlefields of the 21st century, they again face the same philosophy of clever angles and rational scarcity. Alexander Morozov proved that massive budgets can create a strong shield, but only a sharp mind can turn it into a weapon of victory. History repeats itself, and in this race, the winner is not the one with more metal, but the one who knows how to make that metal think.